Have you ever wanted to create your Python objects in more than one way? Or maybe you have a helper function that feels like it belongs with a class, but it doesn't use self. And what if you could build a huge, powerful objects, not by inheriting, but by putting smaller objects together like Legos? If that sounds interesting, you're in the right place, because by the end of this video, you will know the secrets to Python's class method, static method, and the super useful idea of composition. These tools will seriously improve how you write code. This is episode 4 of our object-oriented programming in Python series, and in this episode, we are going beyond basic classes. We will explore two types of methods and learn how to build complex objects from simpler ones. Alright, first up, class methods. So what are they? You already know about regular methods, right? The one that take self as their first input. Self refer to a specific object or instance you have created. A class method is different. Its first input is CLS, which is just a short name for class. This means the method works on the class itself, the blueprint, not on a specific object made from the blueprint. You tell Python you're making a class method by putting @class method on the line right above it. This little tag is called a decorator. Let's set up a simple class person. It has a standard $_init $_ method which take self, name and age to create a new person object. Next, we'll create a wrapper method. This method is just a helper to give us a nice string when we print the object. Now, for the main event, we add the class method decorator. This tells Python that the next method belongs to the class. Let's call it fromString. Notice that the first argument is CLS and not self. The function fromString also have a parameter person_string which takes an argument in the format like Bob25, which is the name of the person and the age. Now I'll define two variables name and age _str and will call split on the person string which has been passed as a parameter to fromString person. We'll use a split method to break the string into two parts, the name and the age str. The age is a string, so we have to convert it to a number using int. So we convert age into an integer type by calling int method, and here's the key part. We return CLS bracket name comma age bracket close. Since CLS refer to the person class itself, this line is the same as saying return person bracket name and age. It runs the init method for us and returns a brand new person object. How cool is that? So why is this useful? The biggest reason is to create different ways to build your object. We call these alternative constructors. Normally, you create a person like this. Person is equal to capital person bracket, let's say Alice, and her age 30 bracket close. But what if your data comes from a string or a file or from the web? Instead of writing messy code outside your class to prepare the data, you can build a class method that handles it all. It keeps your code clean and organized. Let's see our fromString method in action. First, let's create a person the usual way, calling person directly with the name and age. We run it and we have no surprises. We got the output created the normal way. Person name is Alice and her age is 30. Now let's imagine we have our data as a string Bob, 25. Instead of splitting it ourselves, we call our new class method directly on the person class, which is person.fromString, and pass the person data string. Now we'll add a print statement to check what has been created in the Bob object. Now we run it, and over here also our class method does all the work of splitting the string and converting the age, and it then returns a fully formed person object which we store in a Bob variable. We then print it and you can say it's working perfectly. See how clean that is? Person.fromString clearly says what it does. It's a factory for cleaning person objects from strings. So to recap, class method uses CLS to work with the class. It's a fantastic way of making alternative ways to create your object. Next up, we have static methods. These are even simpler. A static method is basically a regular function that you store inside class. Why? Just for organization. It doesn't get self and it doesn't get CLS as its first input. It can't change the object or the class. It's just a helper function that is related to the class. So it makes sense to keep it there. You define it with the @static method decorator. Let us imagine we have a calculator class. We could have a static method to check if a number is positive. Does checking if a number is positive require an instance of a calculator? No. Does it need to know about calculator class? No. It's just a related helper function. Let's build it out. We'll create a calculator class. The init method takes self and a brand as an argument, so each calculator object we create can have a brand name. After defining the constructor, let's add an add method which also takes self, so it can access the brand and print a custom message. This is normal instance method. Now let's add static method using the static method decorator. We'll call it multiply. Notice that it just takes x and y. No self, no CLS. It's just a plain function that returns their product. Let's just add another static method. We'll call it isPositive. It takes a number num and returns true if it's greater than 0 and false otherwise. Again, no self or CLS. It's completely independent helper function that we are keeping inside the calculator class to keep our code tidy. Now let's see how we use them. You can call static methods directly from the class without ever creating an object. To use our static method, we just type the class name calculator followed by a dot and the static method name multiply. We pass number 5 and 10 as a parameter and store its value in a product variable. Now we'll print the value of the product. When we run it, it works perfectly. So we don't need to create a calculator object to use the static method. Same thing for isPositive. We call calculator.isPositive and give it a number. It gives us back true or false. We'll run it and it's showing us the correct output. The 7 is a positive number which is returning true. -3 is a positive number, question mark, it's returning false. It's just a handy tool living in our class. Now compare that to the add method because add is an instance method and uses self. If we try to run calculator.add with 2.3 as a parameter for addition and we run it, it will say calculator.add missing one required positional argument. Why? Because it's an instance function and it will give an error. It will give a type error. To fix this, we'll first define a myCasio object or instance of a calculator class with the brand name Casio. Then we'll call myCasioAdd, which will return the value to the SumResult variable, and when we print it, we'll get the correct result and it will now work correctly. So to summarize, static methods, they are just functions inside a class for better organization. They don't use self or CLS. Think of them as a tools in your class's toolbox. Alright, let's talk about a huge idea in programming, composition. This is how you build big complex things by putting smaller, simpler things together. In the last video, we talked about inheritance. That's for an is a relationship. For example, a dog is an animal, a car is a vehicle. But what about a car that has an engine? A car isn't an engine, right? It contains one. This has a relationship, and that's where compositions comes in. With composition, you create an object from one class and store it inside an object of another class. The bigger object can then use the smaller object to get the work done. Let's build a practical example. A car that is composed of an engine and wheels. First, let's define our engine class. It's simple. We create an engine we give it horsepower. We also write a start method that print a message showing that engine is running. Something like engine with horsepower HP rose to life. Now let's create our car class. The init method or a constructor method takes car make, model and the engine HP. The next two lines are normal. We just store the make and model. But this line is the magic of composition. We create an engine object by calling engine with the parameter engine underscore HP, and we store inside the car's self.engine attribute. Our car now has an engine object. So the composition happens over here. Now look at the next start car method. It first prints the message that the car is starting. Then it calls self.engine.start. The car object doesn't know how to start an engine. It just knows that it has an engine and it tells that the engine to start itself. This is called delegation, giving the job to the object responsible for it. We also define a drive method which prints that the make and the model is driving to simulate the action of car is getting driven. Now let's put it all together and create a car. So we create our car by calling the car function and passing in the detail. So this line will create a new car object by Mustang, and this will also create an engine object inside it. So when this line runs, the car's init method runs, which in turn create an engine object for us automatically. Now let's start the car by calling my Mustang start car. This method runs and it delegates the job of starting the engine to the engine object over here, which it holds. And we run it. We can see the output from both car and engine methods. Finally, let's drive the car by calling the drive method. And now our car is getting driven. This is so powerful. And why? This is often better than inheritance. It's flexible, reusable, and simple. What if you want to upgrade your car with a new engine? With composition, you can just swap out the engine object for the new one. It's like changing a part in a real car. It's so flexible. It's reusable. Our engine class is totally independent. We can now use it in a motorcycle class, a boat class, or anywhere else we need an engine. And also it keeps things simple. The car class doesn't need to know the details of how engine work. It just needs to know that it has an engine and that the engine has a start method. This makes your code easier to understand and manage. A famous saying in programming is favor composition over inheritance. It just means you should try to build things by putting them together. Hazard before you try to connect them in a family tree is a relationship because it usually leads to better and more flexible design. Let's do a quick recap of the most important points. Class methods or @class methods. These use CLS and work on the class itself. Use them to create different ways to build your objects, like making a person from a string, static method, or @static method. These are just helper functions stored inside a class organization. They don't use self or CLS. Composition or has a relationship. This is about building objects by putting other objects inside them, like a car that has an engine. It makes your code more flexible and reusable. Start looking for these patterns in your own code and in code you read. It will make a huge difference. If this video helped you understand these ideas, please hit the like button. It tells YouTube that we are making good stuff and helps other people to find the channel. Don't forget to share this video with a friend who is learning Python. And most importantly, hit that subscribe button and ring the bell so you don't miss episode 5. Thanks for watching Sumant Codes. Keep learning, keep building, and I'll see you in the next one.